Welcome to EDU World Space.
So we have an angle of launch of 40 degrees. We have a world record distance of 23.11 meters. And then we have a y initial equaling 2.00 meters. That is where the shot put was thrown. So we can say that delta x equals vx initial t plus 1/2 a t squared. There isn't any acceleration in the x direction, so this term becomes 0. And we can say that t equals delta x divided by vx initial, and this is equaling 23.11 divided by v initial cosine of 40 degrees. We can also say that v initial t, if we move v initial over, we can say v initial t equals 30.168 meters. So when we're trying to find the y initial, the initial velocity, we can say that y final equals y initial plus vy initial t plus 1/2 gt squared. We're just going to simply plug in for these directly. So we have 0 equals again, the change in height would be 0 here, and then their vyt. Here you would simply substitute this. So you'd substitute this into this. You'd substitute this term into this equation here, and we have 0 equals 32.168, and then plus 1/2. Again, if we're choosing up to be positive, we have to say that gravity is going to be negative, and times t squared. And so we can say that t squared, or rather t, is simply going to be equal to square root of 32.168 divided by 4.9, and this is giving us 2.09 seconds. So it's in the air for 2.09 seconds. This is not the answer. However, we do need this in order to find the answer, so keep track. And so we can say that v initial equals, again, delta x divided by v initial equals delta x. Oh, rather, we can actually better way to solve this would actually be to use this equation. So once we have a t, then we can use this equation and say v initial t equals 30.168 meters, and then we simply say that v initial equals 30.168 meters divided by the t that we've just found, 2.09 seconds. And this is going to equal 14.43 meters per second. Now they want this answer. So this would be the initial velocity of the shot put, given that it achieved a world record distance of 23.11 meters. And then they want this in miles per hour. So we can have 14.43 meters per second. For every 1 mile, there are 1,609 meters. And then there are 3,600 seconds in every 1 hour. And so we get 32.29 miles per hour. So this would be our answer in miles per hour. This would be our answer in meters per second. That is the end of the solution. Thank you for watching.